All right, day 18. We just talked last time about parallelograms and finding those. So today we are going to look at 62 and 63. Two lessons today. So first one, we're looking at classifying triangles. So again, three-sided polygon, interior angles add up to 180, but we can classify triangles in a lot of different ways. We can classify them based on the interior angles, the size of those angles. We can classify them by sides, where they're two sides are the same, three sides are the same, or if no sides are the same. So we've talked about these quite a bit. Again, we know our angles: acute less than 90, right, is exactly 90, and then obtuse is greater than 90. So we can classify triangles by their angles. If it's a right angle, we call it a right triangle. If it's all of our angles are acute, we call it an acute triangle. If we have angle that's greater than 90 degrees, again, we can only have one because we have to add up to 180. We would call it an obtuse triangle. So that's if we do it by sides. Okay, so if we're looking at example 1, the sides of this triangle in order from shortest to longest. So we can use what we know about corresponding angles within a triangle. So if we have 60, 61, then this one would have to be 59. Okay, so 59, 60, and 61. So they're all very close, but the sides are not the same. If all three sides were the same, then it'd be 60, 60, and 60, which it's not. Okay, so we have this triangle right here. Okay, so opposite sides are going to correlate with the angles. So the larger the angle, the longer the side. Because if we were to open up this angle, this side would get pushed out, this side would get pushed out, which would cause this distance from here to here to be greater. Okay, so if this is 59, then this side opposite is the shortest. 60 is the next largest angle, so this side would be the second longest side, and 61, this side. So they all look very close, and they are very close, but we have shortest side, this would be right in the middle, and then this would be our longest side. That's why the hypotenuse on a right triangle is always the longest side. We use a squared plus b squared equals c squared because the hypotenuse is always across from the 90-degree angle, which is the largest angle in a right triangle. So that's our longest side. Okay, so if we have 58, 61, this would make this 61. So segment SR or RS and then QS or SQ would have to be the same because they're both opposite a 61-degree angle. So those side measurements would have to be the same. So it's like in a right triangle, if we have a 90 and then two 45-degree angles, the sides opposite the 45-degree angles have to be the same. If we look in an equilateral triangle, so we identify that by our three sides, they're all three the same. We can call it a regular triangle because regular polygons have congruent sides, but we usually call it an equilateral triangle. So if all three sides are the same, all three corresponding angles have to be the same. Well, 180 divided by 3 is 60. So an equilateral triangle, even if we don't know the side lengths, we know that it has to be interior angles of 60 degrees. Isosceles triangle is where we have two sides that are the same. Like if we had 40 and then 70 and 70, or 45, 45, 90, 40, 40, 100. So two sides are the same, and it's an isosceles triangle, and we know the corresponding, the opposite angles that correspond with the sides would be the same measurement. So this side and this side would be the same. This side and this side would be the same. And then on this one, 40 degrees and 40 degrees, the opposite sides, not the adjacent sides, the opposite sides would be the same length. And then scalene, if all three sides are different, then all angles are going to be a different measurement. They might be really, really close, like the 60, 61, 59 triangle we looked at, but all three sides are different. The perimeter of an equilateral triangle is 2 feet. How many inches is on each side? Well, 2 feet, which is 24 inches. 24 inches divided by 3 equal sides, because it's equilateral, would make each side 8 inches long. If we didn't know that it was equilateral and we were just told the perimeter of a triangle, we wouldn't have enough information. But since we know it's equilateral, then we can work backwards to find the side length. Okay, we'll go over more triangles in the practice set. Lesson 63, we're looking at symbols of inclusion. So again, usually in our order of operations, we say, please excuse my dear Aunt Sally, or PEMDAS, we say parentheses, but that's not all-encompassing term because we have more grouping symbols than just parentheses, as we've seen in some of our problems. Sometimes we have brackets and braces and parentheses all within each other. So we have symbols of inclusion within symbols of inclusion, then we got to start in the innermost and work our way out. So brackets are just these square drawn ones. Again, not absolute value. They have the little rounded edges right there. So don't get these confused. And then we have braces, okay, which is kind of these squiggly ones right here. And then obviously we've talked about parentheses. We also have symbols of inclusion, like if we have a big long expression in the numerator, like if we have something like this is just a quick example. So we're not solving for x, but if we had this, hey, well, we're dividing because we have, a division bar. It's a fraction, but then everything in the numerator and the denominator, even though it's addition and subtraction and addition, we would do those first. Let me give an example that we could actually. Okay, we have addition and subtraction and division. Well, normally we divide before we add or subtract. That is true, but since we have an expression, two terms in the numerator and the denominator, we perform those operations first. So expressions in the numerator and the denominator act as their own grouping symbol. So even though we don't have parentheses drawn, we could draw them in if we wanted, but we need to do this addition first, then this subtraction, and then we do our division. Once we have it simplified down, it's 8 divided by 2, which is 4. So that one may seem a little weird because, well, we always divide before we add or subtract. That is true, but the numerator, if we have a big, long binomial, trinomial, polynomial, whatever, we have big, long expression in the numerator or in the denominator, it's the same thing, doesn't matter. We have to perform that calculation first before we divide, because we can't divide 3, are we doing 3 divided by 4 or 3 divided by -2 or 5 divided by 4, 5 divided by -2? We're not doing any of those. We have to add and subtract and simplify, and then we divide. So side journey there, but those are also symbols of inclusions when we don't even have necessarily symbols. Okay, so it's implied inclusion. So we would do those first. And then within our grouping symbols, we still follow order of operations. So we have this example here. Well, we have brackets and parentheses. Which one do I do first? Well, the parentheses are inside the brackets, so do the innermost first. 12, 5 plus 7, 15 minus 12, and then 20 minus 3, we get 17. Okay. If we have 12 minus 8 minus 4 minus 6, and this one is absolute value, so that's symbol we've talked about in the past, but that means that it's just a direction. So it just has a value like distance from the origin. So absolute values are always positive. So the absolute value of 5 is 5. The absolute value of -5 is also 5. Doesn't mean flip the sign, it just means it's always positive. So if we go in here, we do 4 minus 6 is -2, but the absolute value of -2 is +2. So I have 8 minus 2 plus 2, which is 8. And I have 12 minus all of that, which was simplified down to 8. 12 minus 8 is 4. And so you still follow your order of operations. If you have exponents within the parentheses or parentheses within your brackets or whatever, you follow your order of operations even within your order of operations. And then, as I was saying, the division bar acts as its own grouping symbol. So we would do 4 plus 5 times 6 minus 7. Okay, well, we do the numerator and denominator first, and even within that, we follow order of operations. So I multiply first. 5 times 6 is 30. 4 plus 30 minus 7. 30 plus 4 minus 7, okay, gives me 27. 9 minus 8 is 1. 10 minus 1 is 9. 27 divided by 9 is 3. If we started dividing before we did all this, it would obviously be an incorrect answer because we got to do everything in the numerator, simplify it down, everything in the denominator, simplify it down, and then we get our answer. Now in your calculator, you could read through this. I would probably do numerator, hit enter, or maybe even parts of the numerator, depending on how complex it is. Do the denominator and then hit enter, and then do a separate equation in the calculator once I know what the numerator and denominator are. It's just, there's a way to do it, but if we get these big, long expressions in our calculator and we miss a parentheses, or, it may read this as 4 plus 5 times 6 minus 7, and then 7 divided by all of this, or 7 divided by 10, and then minus 9 minus 8. So we just have to be really careful of how we input things into our calculator, because we may be thinking certain order of operations, but the way it's computing and calculating may be different based upon where we put numbers and stuff like that. So I can show that on the board when we get to class. All right, there's our practice set. That's all we got. So good job today. We will see you guys soon.